I want to talk about a theory from the literature in learning. There is a very famous professor in this literature, uh, the late Professor Argelis, Chris Argelis. Let me say his name here. Chris Argelis. He was a professor at Harvard, and he was actually a pioneer in action learning theory. One of his well-known theories is about single loop versus double loop learning. Let me just give you an example. Let's say this example is from the late Professor Jake Ma, who was also at Harvard, and he told the story that, let's say, in this room we have a goal. Our goal is to keep the temperature at 20 Celsius. Okay, so our goal is keep the temperature 20. But the problem is that the temperature is not staying steadily. Let's say when the temperature goes down, goes below 20, we turn on the heater. We turn on the boiler. And then the temperature will go up, right? But then soon the temperature will go down again. And whenever the temperature goes down, we start the boiler, we start the heater. And then the temperature goes up, and so on and so forth. So it's not staying at the desired level. It always goes down, goes up, goes down, and goes up, fluctuating. So after a while, I was sort of exhausted, and I tried to fix this problem once and for all. So I look around the room, and then I found out that at the back of the room there was a broken window. Aha! That's the reason. That's the reason why the temperature does not stay at the desired level. And I decided I gotta fix the problem. So I changed the window, the big window. I replaced it with the new one. And then after that, the temperature stays at the desired level. So I don't have to go up and down all the time. What does this story tell you about? The fluctuation, I mean that I turning the boiler, I turning the heater, that's kind of a symptomatic solution. I reacted to the symptom. What about replacing the broken window with the new one? That's sort of solving a problem at a fundamental level. And now let's think about this model. There are symptoms, right? And these symptoms cause some consequences, outcomes. And usually we have goals. In other words, let's say our goal is I want to keep this room at 20 Celsius. And the consequence is room temperature. And then I compare these two. And if there is a fit between the consequence and my goal and outcome, then it's okay. I reinforce this whole thing. On the other hand, if there is some discrepancy or mismatch between my goal and consequence, I gotta rectify the problem. And now let's say I directly treat these symptoms. The symptom is my temperature goes up and down, and corrective measures for symptoms is turning the boiler, right? So I turn the boiler, I turn on the heater, and therefore I eliminate the symptoms. Symptoms in this case going down below 20. But as we can see in that example, this one goes on and on and on and on without stabilizing solutions. So it's always repeat over and over again, no permanent solutions. That's because our collective measures stops at symptoms. And symptoms is the room temperature, going below 20 Celsius. Or that thermometer we are observing. So this is a sort of a short-term and symptomatic solutions that cannot solve the problem at a fundamental level. Then what about the replacing the broken window with a new one? Chris said that's double loop learning. That's the double loop learning. Double loop learning, which is a long-term and fundamental. In other words, whenever we see there is some discrepancy between my goal and outcomes, I want to eliminate the root causes, not just the symptoms. So I will go to these root causes, in this case, broken window. So I change the window. That's my fundamental problem solving. Root causes. Root causes are eliminated. And as you can see, single loop learning is short-term oriented and double loop learning is long-term oriented. And one might say that the double loop learning is better than single loop learning. I would just say in the long run, double loop learning is important. But we may not say that the double loop learning is more important than single loop learning, or vice versa. Let's say there is some old town. There is an old town where all these houses are mingled together, meandering roads, and everything is old style. And all this fire safety is compromised, and so on and so forth. And now there is a fire. There is fire there. Then there are two approaches, right? One is, okay, we gotta make a fundamental change there, and therefore we probably need to build new facilities, or we straighten these roads, and we probably install different electricity equipment, electricity facilities, and so on and so forth. Of course, by doing so, we may eliminate the root causes of the fire at that local, traditional and old town. But there is a fire burning there, so you gotta extinguish it first, right? You gotta extinguish the fire first, even if you worry about, even if you plan for the future. In other words, on the one hand, you have to think about the long-term double loop learning, and at the same time, you gotta do something you have to do immediately. The point is that I cannot ignore one at the cost of the other. We gotta apply these two, single loop learning and double loop learning, at the same time. On the one hand, we solve the problem right now, firefighting. And on the other hand, I have to plan for the future so that I destruct the whole town so that it becomes more, robust against any fire in the future. And I would say that's the integrated learning. And in this model, it's not just about singular corrective measures. It's not just about double corrective measures. It's both. So the question is how to allocate these resources into these two. So the question is not just about taking one measure at the cost of the other, but basically the question is about how to balancing these two approaches, these two learning approaches, these two problem solving approaches in an optimal balance. So on the one hand, we deal with these short-term immediate problems. So we do the firefighting right now. And at the same time, we want to make sure that the same problem does not repeat in the future unnecessarily, so frequently. So we got to think about the long-term fundamental solutions at the same time. I would call that as integrated learning. And in the topics we learn in the context of supply chain management in the next chapters and in our next lectures, this approach, integrated learning approach, is very important. In supply chain management, on the one hand, you should not ignore the immediate problems. If you cannot survive today, there is no life in the future, right? So you have to deal with the current problems, but at the same time, you should not be obsessed with the current problems only. You gotta have some extra resources. You gotta have some people. You gotta have some, a time or attention that must be devoted to the long-term and fundamental problem solving. In other words, for the double learning. How can I balance these two in an optimal, in a most effective way? That's probably one of the very important roles the manager must play.